Coming up on this episode of the IoT Inc Business Show.
We've always done machine-to-machine connectivity. Millions of pieces of hardware out there that are connecting everything from in utilities, spaces, factory automation, process automation, warehouses, buildings, vehicles, all kinds of kind of down and dirty edge of networks where things are messy. It's just a different environment than the IT closet.
Sensors from the M2M world are evolving into connected sensors for IoT. Same sensor tech, but now sensors need to communicate outside of a local and often proprietary network. Goodbye 35-year-old Modbus using SCADA of yesteryear, and hello layered communication, needed for the Internet of Things to onboard billions of devices. In this episode of the IoT Business Show, Mike Fahrion explains not only the anatomy of today's connected sensor, but also why we're moving to a layered communication stack.
All this and more on this episode of the IoT Inc Business Show. The people, the business, and the technology of the next generation internet. This is the IoT Inc Business Show. And now, here's your host, Bruce Sinclair.
Hello and welcome to the IoT Inc Business Show. This show is made possible by sales of my book, IoT Inc, published by McGraw-Hill, and the IoT Inc Certified IoT Professional, or ICIP, online training and certification program. Become a certified IoT professional by completing the program's 3 courses: ICIP Technology, ICIP Business, and ICIP Strategy and Digital Transformation. Details of which can be found at www.iot-inc.com. That's www.iot-inc.com.
With me today on episode 3 is Mike Fahrion. Mike is Director of Product Management at B&B Electronics and is the company's Internet of Things strategist. He is an expert in data communications with over 20 years of design and application experience at the edge of networks in remote, harsh, or uncontrolled environments. Mike is a speaker and an author and has a newsletter, eConnections, which has over 50,000 monthly subscribers. Given his experience on the edge, I thought Mike would be a great guest to walk us through the sensor side of the business. Mike, good to speak with you today. Thanks for coming on the show.
Thank you, Bruce. Appreciate it.
So, uncontrolled environments, huh? I guess you also have a teenage daughter?
I do, as a matter of fact.
Well, we won't go there. You know what? Let's just get right into it. Tell me a little bit about yourself and your background in IoT.
Yeah, well, I got my start in electrical engineering, doing all kinds of product design for M2M type connectivity. It was always typically somewhere in some part of called the industrial world. And by industrial, I basically just mean non-consumer. But from there, I had roles in engineering management, business development, some technical marketing, and product management. But I've always been really fascinated with the interface between people and technology. So that's where I have my most fun.
And when has what you're doing been called Internet of Things?
Boy, this whole IoT thing is just gone explosive over the last 12 to 18 months, really.
Okay, that's when you've seen. Has that been the biggest shift for you? That's when it's like you're starting to identify yourself as an IoT guy now. Is that possible?
Well, I think it's the market starts to kind of brand you that way, whether that's the best term or not. And it's a great term in so many ways, but it's becoming so hyped that I think it's starting to confuse people a little bit, frankly.
Yeah, no, I agree. It kind of has a lot of meanings, but it sounds like, from a commercial point of view, your organization B&B is focused on commercial, industrial infrastructure. Is that fair?
Yeah, we've always done machine-to-machine connectivity. So we have millions of pieces of hardware out there that are connecting everything from in utilities, spaces, factory automation, process automation, warehouses, buildings. Vehicles, all kinds of kind of down and dirty edge of networks where things are messy. It's just a different environment than the IT closet.
Yeah, and now I guess what I'm reading into what you're saying is in the last 12 to 18 months, M2M has wanted to kind of reach to the outside world and be connected to to that internet or that interweb of the Internet of Things.
Yeah.
Is that kind of right?
Yeah, I think, and it's a really fascinating dynamic going on, and I think it's a combination of a number of things. One is obviously the technology. So there isn't some pivotal event that happened in the last 12 months that said, well, some new thing just got invented and now we can have Internet of Things. Reality is we've had it for a long time, but the technology is getting more cost effective. So that's one piece of it. Things that used to cost a fortune to do are now much easier, both at a hardware level where Moore's law and all that stuff keeps kicking in, and we can get these great modern electronics type devices. But there's also and I'd say also at the software platform level, to be a platform service provider 10 years ago and do some sort of web-based platform had a pretty high barrier to entry, where today it's a minimal barrier to entry. But the biggest thing that I think is interesting is there's a cultural shift as well. So all of us have been retrained, and there's these new generations of engineers. We're used to having amazing amounts of connectivity in our pocket with smartphones and things that we wouldn't have even considered a decade or two ago in the industrial and the plant floor. All of a sudden, the consumer world has influenced us greatly in our vision of what can be done.
Yeah, no, that makes sense, and I think you're right. The new generation sort of looks at their phone and says, "Well, I can connect up to my bank. Why can't I connect up to my factory or whatever the case may be?" Yeah. Well, listen. Before we get into this more, I want to learn a little bit more about you. You have a teenage daughter, like I do, but tell us what's an interesting fact that most people don't know about you.
I'm really an outdoors guy. I'm always happiest doing whatever I can, wherever I am outside. And as funny as it is, as much as I'm kind of engrossed in technology and just fascinated by it, I'm also get a huge kick out of being just way off the grid. So get me out someplace where there is no cell phone connectivity and no roads, and I love that contrast.
Yeah. And do you live in an area where you can actually get out of range?
Well, you have to work at it.
Yeah.
It can be done. Yeah.
Now, tell me something you're really proud of. What have you done that you can look at and say, yeah, that's something I feel good about?
Yeah, as I look back, I have all the things with family and kids, but one thing I really enjoy, when I look back at all the different things I've done professionally and personally, I like being involved as a change agent. Whether it's helping a company navigate through a change process, or maybe the local youth sporting organization, sports club. How to bring the most value to the kids. It's such a fascinating thing, because change is just such a necessary thing just to survive. Yet human nature seems to be so just one of resistance to change. So it's a fascinating topic for me, and I just love getting involved in it, regardless of whatever the role.
Yeah, no, and I agree with you, and I guess I think I identify myself that way too. But you have to have a thick skin, though, right? I mean, because like you said, change is really difficult to implement, and people kind of like just to keep doing what they've always been doing. So you have to be willing to take a few arrows, I think, for in the name of change too.
Yeah, no, that's I can identify that very personally.
Yeah, you're pulling out a few as we speak. Well, okay. Well, let's talk about IoT sensors. What I'm interested in is let's start maybe if you can give us an overview of a sensor. What's the anatomy, both from a hardware and a software point of view.
Yeah, and this is it's a surprisingly huge topic. The sensor market itself is $40 to $80 billion space, and there's
is that right?
Yeah, it's big, and there's hundreds and hundreds of just categories of sensors. Thousands of manufacturers of sensors, and I would presume millions of different part numbers. So it's such a bigger world than what you might envision. But if we boil down to just the basic anatomy, let's start with, a sensor is really just something that has a reaction to some physical stimulus. So a tire pressure gauge is, I would say that's both a sensor and an application layer in one piece. So it's got a little pressure sensor in there that causes a reaction. It causes a little stick to jump out and tell you how many pounds of pressure are in your tires. So that's both a sensor and a presentation layer, if you will.
Okay.
So the sensor, and sensing is such there's just a huge variety of devices out there, from measuring pressure, temperature, humidity, flow, scales, chemicals, gases in the air, things like that. So with that, some of those sensors are very commodity type products, and some of them are just hugely specialized. So it lends itself to it. There's an enormous ecosystem of sensor providers out there. But I guess what it boils down to when you start thinking of from a business level, so boy, if there's something out there that you want to measure and you want to measure it because you want to be able to manage it, whether it's your consumption of resources, electricity, water, whatever it might be, maybe it's compliance driven with ever-changing compliance regulations. Or it's just pure efficiency. You want to make better use of your assets and your resources. There's a sensor out there. There's a way to measure that. And then there's two parts to it. First, you need the thing that can actually provide the measurement. And then you need the system or the device that can take that measurement and then translate it up into wherever your application is. So in our tire pressure gauge, we just need to get that tire pressure to the other end of the stick and show you a visualization of how much pressure is in that tire. But in the world of IoT, probably means we're taking something from the physical world. Maybe it's the level of coal in a bin, and we want to tie that into maybe your ERP system thousands of miles away that wants to manage that inventory and monitor that inventory remotely.
Right. And so that's the second part you're saying. What do you call that? So that, and that's something I always get a little bit confused on. Is you have the sensor, but then what do you call the rest of the thing that connects the sensor to, this ERP system, for example?
Yeah, so we call it a bunch of different things, but it depends, I think, a little bit on I refer a lot to the connectivity stack. So guys get away with this all the time, right? They have our 7-layer OSI model. So if they can do it, I think maybe we can do it too. But it is so what is a network? It isn't just the physical layer. It's not just the application layer or the transport layer. It's the stack of things that you have to put together to get from that bin full of coal all the way up into your ERP system. So it starts with, I can walk through maybe some of the piece parts.
Yeah. Why don't you do that?
So we'll start with the sensor itself. So maybe for the sake of discussion, monitoring level in a bin, we'll typically often use a ultrasonic sensor for that. So there's a number of different manufacturers and all kinds of different physical form factors. But basically what it's doing is it's sending a little ping, ultrasonic ping down and measuring the time to get back. So we mount the sensor up at the top of the tank, and it's going to tell you how close to the top of the tank the level is. So now that sensor is going to have an output to it that's probably going to be an analog output, meaning it's going to produce maybe a 0-volt output when it's at the bottom of its range, and then vary on up to a 5-volt output when it's at the top of its range. So if we get 2.5 volts out, it means our bin is half full or half empty, depending on your level of optimism. Right? So now we've got that 0 to 5 volt output. Now we need to connect that into a measuring device. So this is where the stack starts to come in. Now, the awkward thing about sensors, the physical things you want to measure, they're often in difficult locations. So it's sort of a drag to have to wire, to put wiring on up to the top of this bin. So wireless and sensing is starting to really go hand in hand really frequently, especially in this IoT space where people want to go in and add in a kind of an overlay network and monitor something that maybe they weren't monitoring before. So it's some existing application, and what we really need to do is minimize the total amount of labor that goes into that. So wireless is really attractive. So we've got a box now that we're going to wire our sensor into. So it's got a 0 to 5 volt analog output coming into an input in our monitoring node or our sensing platform. It's going to convert, inside that box is a microprocessor and some analog to digital conversion circuitry, and then some communications. So we're going to convert that into a digital signal, and if it's a wireless sensing node, we're going to push that out over the local wireless network. And most likely, what most of the architectures look like is we're sending that over a local wireless network, and it's going to be collected by a gateway. So maybe in this fictional site we're making up, we've got a kind of a warehouse area with maybe 10 or 20 bins full of coal. It'd be a great application for a wireless mesh network. So we could drop in a sensor at the top of each of these bins. It's got your ultrasonic sensor reflecting and giving us back the level in the bin, and it's going into this wireless sensing node. And that sensing node builds a self-forming, self-healing wireless mesh network to relay that sensor data back to a gateway. So that gateway now starts to look a little bit more like a traditional IT piece of equipment. It's probably got an Ethernet port on one side of it, maybe a cellular connectivity for those places that are truly remote. And then it's got a local antenna that's collecting data from our wireless mesh sensors as well, our sensing nodes.
Okay, so let's zoom back on this I guess, this secondary box. So you have where it holds part of that stack that you were just talking about, the MCU. It's got the ADD converter. It's got some wireless I guess, interface on there. Now, what's the software that we're looking at? What's the important software if we look at it now from a software point of view?
Yeah, when we start thinking from an IoT perspective, we could probably put this in two categories, because everything we've just described is really nothing new to the world. We've been doing it in the controls and the industrial automation space forever, and in that world we always called it SCADA, supervisory control and data acquisition.
Right.
But that was always very much a siloed application. You wouldn't expect, for the most part, to pick up your cell phone and just see an interface from a traditional SCADA application, or you wouldn't expect to be able to pull that into various ERP systems very easily. It was meant for kind of within the industrial operations technology group. But what's changed, though, is I guess in that world there were some specific protocols we'd use. The industrial automation protocols, Modbus, the Allen Bradleys of the world, the Siemens, all those folks. But the problem with that is that stuff doesn't scale well up into web type applications. It's stored and represented in a register, and it's sort of an obscure reference that if you put that in front of your web developer, your IT guy, and said, just pull that data out of Modbus register 4004, he would have no idea how to use that in an application. So when we look at this now through an IoT set of lenses, we say now what we want that hardware to be, and the software inside that hardware is, I want it to convert it into what I would call a semantic protocol. I want some friendly data to come out of this. So I don't want some bits and bytes that represents the level in the tank. I'd like that sensor to send me some very descriptive data that says, on tank number 14, the level of coal is 27 feet. Maybe here's the, so it's giving you the actual data in real units. It's giving you the engineering units. Maybe it's giving you the geolocation of that tank. It's giving you a friendly name of that tank. So now it's transmitting all that data, a little bit more verbose, but transmitting all that data up to the network. So now a remote developer doesn't need to know anything about the producer of the data. And that's one of the big distinctions, I think, in the IoT, is we really want to separate the consumer from the producer. Meaning, I'll consume a bunch of data every day on the web. And when I go out to the University of Hawaii's website on, studying something about dinosaurs, I don't want to know anything about how that data, I don't have to know anything about how that data was put into that website. I can just consume it without knowing anything about the source.
Right.
And that's the difference, I think, between SCADA and an IoT application. In SCADA, we need to know every little detail about the source before I can make use of that information. In IoT, I want to look at a lot bigger scale. I want my developers to be able to just use this data as facts in a database, and be able to start to manage processes and things based on that without having to be expert on the entire connectivity stack.
Yeah, no, that makes a lot of sense. So you're saying an important part of the software is the contextualization of the information in some sort of semantic protocol, and where does that fit in? Yeah,
so we put it. I think that the more you push the intelligence out to the very edge of the network, the more scale and power you can really deploy. So we do that right out at that edge sensing node. So it's not the sensor itself. Remember, there's too many sensors in the world, and they're just little mechanical, electromechanical, or chemical devices. But when we convert that now into data we can transmit over a network, right there at that site is the best place to add that semantic level of information. And we do that, we're not doing that in older protocols like Modbus and such. We use JSON, so stuff that any web developer can say, they can read that in their sleep. They know exactly how to pull that and put it into databases and applications and such. So now instead of telling you that here's some bits that represent, the temperature in my office, I could tell you, the temperature in Mike's office at 1:15 p.m. was 72 degrees Fahrenheit. And if you also like to know the geolocation of Mike's office, I could tell you that as well. Or how much battery life is left in the sensing node that sent you this information, or maybe the quality of the wireless network connection that data traveled over. So I can really provide a lot of descriptive information by putting that intelligence at the very edge of the network.
Yeah, no, that makes a lot of sense. So you organize the information in adjacent data structure so that when they have to hook into it from the application or from whatever application is going to be consuming it, they're just using straight old JSON, to get the information.
Exactly. So now you don't need a sensor expert or anybody with any expertise about how that physical measurement was taken for them to be able to consume that data. So that lends itself to, first, a lot of speed of development, and also a huge ability to scale.
So now, is this with a little agent or a little piece of code? And you put it into, I guess, the memory that's on the device that talks to the sensor directly? Is that what that is? It's like a piece of code?
Yeah.
What's the structure?
That's how we do it. So we have a little microprocessor out there at the edge that, so we're not only we're digitizing that data, but then we're adding in all that extra semantic information, and a lot of that is configured by the user when they deploy this thing. That's when they need to tell us that, hey, I'm measuring this information on this coal bin. Here's what I want your friendly name to be. Here's the network I want you to join. Here's what I want your engineering units to be. And maybe even here's where some trigger thresholds are that are particularly interesting to me. If this, you can go ahead and send me a report on how much coal is in this tank once an hour. That's pretty interesting to me. But if it ever goes empty, that's really interesting to me. I'd like to know that right away. Or if it ever goes over 100% or at 100% full, that's interesting to me too. That both of those conditions mean something went wrong. So send me an alert right away. Mm-hmm. So programming that edge device with some intelligence to let it kind of operate in a true value add manner is a pretty big deal.
Now, who does that programming? Is this done by specifications from the end user and then you take it and do the programming, or do they actually do the programming themselves?
Yeah, the way we do it is we allow the actual user installer to do the programming themselves, but the way you program our devices is with your smartphone. So it's basically using a Bluetooth interface to the sensor node. So in the old days, you'd have a console port on your IT equipment, right? And you'd have to drag your laptop out there and plug into some sort of serial port. I don't think that's the way of the future. So we said, everybody's got a smartphone or a tablet. So we created an application there, and now you can connect. You basically pair with our Bluetooth radio inside, and that is our console port, and that's how you program and interface with the device locally. And then once you're done with that, it's now attached to the network, and you can walk away from it, and it'll just go on and do its thing.
So you do it in vitro in the sense that because I'm just wondering from a scalability point of view, I would thought that you would have done it, for all of them all at once and then put them out there. But what you're saying is you put them in the field and then do them while they're in place. There's advantages because of the mesh networking, and it's all happening at one time, or is it scalable to do them one at a time, but just by moving around a phone? Yeah,
and there's other methodologies as well. It depends a lot on, you almost have to think of the channel to market and how the thing is getting installed. So if it's something we're going to step and repeat, so perhaps maybe it's a warehouse monitoring system, for example, and it's monitoring environmental conditions and doors opens and closes and level of inventory on pallets via weight or height or things like that. And maybe we're going to replicate this now in 50 warehouses. Well, that's probably going to be done through a system integrator, some sort of service provider who's a specialist in that warehouse management business. And they're probably going to take our platform and pre-configure it with all the the appropriate sensors for that application. Right. And then now they can just kind of drop it in and deploy it.
Makes sense. Yeah. Okay. Well, I'm a firm believer that to make the right business decisions, you need to understand, the technology. Not far enough to implement it, but at least understand how it all goes together. So when you're making a buying decision, when you're making, when you're trading off, I guess, different choices, you have that technical context. And right now, IoT certainly isn't plug and play. So, the onus is on the business person to kind of have a little bit of this knowledge. But this is a good segue, Mike. That really helps. The way you illustrated it with the example specifically, breaking down the sensor from the rest of the box, or I guess maybe the sensor platform. Let's move now more into, from a business perspective, let's move into more to the business of sensors. And, the first question I have is, what's the process that you go through with your customers? And maybe you could also articulate who the customers are, but, okay, I need this type of sensor. How do you find it? I mean, is it like a catalog you go to, a big database? I mean, how is that first step? Because I think it's pretty important. How's that first step done?
Yeah. And I think if I step back just one step, I find that our customers fall into one of two backgrounds, if you will.
Okay.
So half of them come from an IT type background, and they understand the benefits of semantic data protocols, and they understand JSON and that stuff in the MQTT transport layer that we use. They understand that stuff really well, but they don't have any idea the sensor world is totally new to them, and there they need a lot of help. The other category of customer is somebody that comes from the operations side. In those cases, they typically know exactly what they want to measure. They probably have already had some of the sensors. They just need help with the connectivity side.
Right.
They're already doing the sensing, but they want to avoid, see if they can not have to use the guy with a pickup truck and a clipboard to go out and measure all these things manually with these sensors. They want to provide automation on the back end of that for the connectivity. Mm-hmm. So, but when we need to get involved, so when you start out and say, boy, here's a process I'd like I want to better manage this process. So from a business person's perspective, it usually comes down to, looking at something in your facilities or in your business. You say, I have no control over this particular process. I wonder what's going on here. And there's something I'd like to know more about. And maybe it's, it could be such a wide range of things. It's usually around some degree of optimization, but maybe it's around energy consumption. Maybe it's around unwanted use of other resources. Maybe it's about waste or just human productivity, all these sorts of things. But usually, they can at least identify if a customer can come up with some sort of problem statement that says, I'm having a huge amount of variability in my power consumption of this process between the first shift and the third shift. We can usually start to talk to them about, okay, well, tell us what kind of machines or what sort of process this is. We can either, depending on how deep the whole thing goes, might mean that they need to work with a systems integrator. Say, wow, this is going to be a big project and big program. We could hook you up with a partner. Or it might be something that we can just do over the phone and with one or two on-site visits to say, let's look at what you're doing. We'll come home and do some research to say, you want to monitor carbon monoxide and carbon dioxide and ammonia levels in the air around this process, and you're looking for, temperature and humidity and power consumption. Once we see the devices that you're trying to, or the environment you're trying to gather that information from, we can do some homework, come back and recommend, specify, even qualify appropriate sensors for that application. Or, like I said, if it's a more involved thing, then we say it's probably best to get an integrator involved, because there is, at some point somebody has to deploy all these things, and there may be some level of expertise required just to do the installation and such.
Now, does standardization come into play here, or is it just so far off? I mean, you were talking earlier about the siloed, nature of, where the industry came from. There's so much effort that's happening right now in standardization in a whole bunch of different places in this stack that you've been talking about. Does it matter at this point? I mean, that you standardize on anything in particular?
Yeah, I think in the long term, standards always win, but there's always a land grab process that happens in the front end. It's really hard to navigate because everybody is trying to get their own brand on things. And I would say to one degree that the last thing, I say this with about 90% conviction, but right now the last thing the IoT needs is more standards. We have so many things to choose from. There's lots of great stuff out there. So we've done some standardization on things like our transport layer that happens over IP is something called MQTT, which is an open standard now. Facebook Messenger is probably the largest deployment of it, but it's a great way for publishing sensor data up into large scale applications. So we chose that, and we chose the JSON protocol instead of something proprietary. As a standard way that lots of people can now consume our data. Even at our wireless end of things, from the physical hardware, we're based on an 802.15.4e wireless mesh networking standard. Be a little careful here, because as we get into this area, we can say we're based on that .e networking standard, but that does not really imply interoperability yet at this stage. So there are a mix of standards, and we absolutely seek out to use standards-based wherever we can. When you get down to the sensor side, it's a little different. It's so many different physical interfaces. Now that in general things have standardized to say, well, if you're buying a sensor, you can get just about any sensor on the world, and you could say, I'd like to have a 0 to 5 volt output on that sensor, or 4 to 20 milliamp output on that sensor, and odds are good that sensor manufacturer probably makes that particular, maybe it's an ammonia sensor for measuring how much ammonia is dissolved in the atmosphere, and that sensor is probably available with a variety of outputs, and so you can pick one that fits your hardware needs and your interface needs.
Okay, so at least at a minimum, the MQTT side and the JSON side is what you're adding on, but the IP you are going to want to choose. You're at least standardizing on IP, and then from a network interface point of view, 802E. But like you say, I guess that's hardly really a standard yet, but it is sort of working in that direction.
Yeah, it's all based on a collection of standards, but standards don't always guarantee interoperability. So I want to be a little careful not to use the two, not to give the wrong implication.
No, I have a question. Are you out in the outdoors, and is that a search and party rescue that's searching for you right now?
I wish it could be.
They're circling, Mike. They're circling. All right, let's talk about costs. What I guess first of all, how much should people expect to spend on the sensors? I mean, I know it's going to really depend on industry, but I'm just looking for some. Again, we just want to ballpark it here a bit.
Yeah. So let's start by putting some wild rails on it to say you can buy sensors that range from pocket change up into thousands of dollars.
Okay.
But it depends a lot on what you're trying to measure, then a lot on what sort of environment you're doing that measurement in terms of how rugged and robust it needs to be. Temperature sensing, those are low-cost sensors. There's a number of different physical ways to measure temperature, and you're generally looking at sensors, depending on the packaging. Again, you're in the probably tens of dollars to measure in some sort of reasonably rugged package.
What about that sonar one? I thought that was pretty intriguing.
Yeah, so ultrasonic level sensors, you can easily get into the hundreds of dollars.
Oh, really? Okay.
Thing. So, in gas sensors as well. I've got in my office here, I've got oxygen sensor. I've got a CO2 sensor. 100 to low hundreds of dollars on up to if you get into kind of critical systems, like maybe if you're measuring the level of carbon monoxide in the atmosphere, because if something goes wrong, it could kill somebody. You probably want to have a very robust sensor with some strong calibration capabilities and things like that. So you can really, there's almost a sensor for every application, and there's a price range that's kind of fit for purpose for all up and down the food scale.
And if you were to look at maybe the last, 2-3 projects that you've worked on, what would be the average pricing on a sensor? Or in a sensor, sensor and then sensor body, I guess the both.
Probably. Again, it depends so much on. Somebody could say they want to do environmental sensing, and it's one answer if you want to know what's the temperature and humidity in a warehouse, and it's another one if you want to know on the side of a volcano.
Yeah, right. Okay.
But you probably want to think in terms of tens to low hundreds of dollars for specialty type sensors.
Okay.
And then the sensing platform itself, again, it depends on the application. Where we're having a lot of success right now is with our new platform is in outdoor. It's a rugged platform. It's IP67, which means it's waterproof and dustproof. So you can just bolt it on the side of a roof of a building, or bolt it on a tractor, or an outdoor application, or on the side of a steam boiler, things like that.
This is the Wizard platform?
That's our Wizard platform. And those nodes are in the $400 to $500 range per sensing node. And each sensing node can accommodate several sensors itself.
Okay. That makes sense. Okay, well, no, that's helpful. It gives at least it sort of brackets things a little bit. What else? What other costs are associated with sensors? I mean, is it just an upfront cost? But I would imagine, are there operational costs? Are there what are some other things that someone that's going to be making this investment need to consider?
Yeah, certainly you have the upfront cost of the sensor, the sensing, the hardware platform. The couple things to think about, especially because we're putting an IoT lens on this, is these things are remote, right? So it's a kind of a large-scale remote monitoring application. So that probably implies we might be sending our data up over a cellular network. So you're going to have ongoing charges over cellular. So that's something you want to be aware of. Now, a sensor doesn't need much data. So this isn't like a teenager's data plan sort of sending tens of bytes at a time.
Yep. Yeah.
But if you're talking about a system with 10,000 sensors all sending tens of bytes of data at a time, you want to think about that a little bit. The other cost is the data storage transaction cost itself. This is a little different than some of the, so if you look at cloud hosting type thing, you might have a data storage fee. You might also have a transaction fee. If you're talking with sensors, you're probably talking about a very large scale of very small devices. So none of them are going to send you a 10 gigabyte file, but you could have 10,000 sensors all sending you a transaction that has 100 bytes in it. So it's a little different. It causes a little bit different load on your network, if you will, than traditional IT type office level communication, where you might have large sporadic files. Now we're going to have a huge number of transactions from a lot of small producers.
Yeah. Now, are you finding, the connectivity providers, are you finding that they're building plans to match that? Low bandwidth per, but a lot of connections. How is that playing out?
Yeah, certainly the cellular providers, the carriers are reacting to this, and they're, I think we've probably all seen all they would all like nothing more than to put their own brand on the IoT, if you will.
Oh, yeah.
But interestingly, so they're reacting and creating, data plans and such that are more friendly towards this sort of stuff. But I found it interesting. I was in a conversation with somebody over the weekend that pointed out, the salespeople at one of the major carriers, they said they're all still commissioned on the number of connections that they sell.
Oh, really?
Which is, I think, a little bit of a throwback that probably might say that they're not all the way there yet, because it would seem strange to me that a salesperson might get commission on, think of somebody that might want to monitor 10,000 vending machines.
Yeah, sure.
But each of those vending machines only needs about a 10 kilobyte plan per month. that's
Yeah, no, and that's what I'm wondering, are there plans that say that, because, our plans, and my daughter blows through that data plan, I'll tell you that, but, it's on, well, I guess it's 10 devices within the home, but I mean, it's more, it's 10 devices and it's 10 gigs or something like that, right. Which wouldn't make a lot of sense here at all. I mean, so are you finding, or are you even involved in that? Actually?
Yeah, and the reality is you have to be involved in that, because a lot of, so our Wizard platform, our wireless sensing nodes, they connect to our gateway. Gateway, you can get it as an Ethernet gateway, but a lot of customers prefer it configured as a cellular gateway, which
right. Depending on the situation, sure.
Yeah. So we help customers navigate that. So I would say two things. Carriers are absolutely reacting, and carriers very much see their future growth model being driven by machine connectivity, because they've already sold more than one data plan to every person
Yep.
in the country, right? So they need those that machine connectivity is a big part of their future. So they are reacting to that. So it's far easier to have a call like that with any of the major carriers today than it was 5 years ago. And there's also an industry that has sprung up, just over the last decade, I'd say. So it's not terribly new, but it's really sprung up when we started doing wireless and machine-to-machine. That's somebody called an MVNO, so a mobile virtual network operator.
Right.
These guys are basically, they work with the major carriers, and they're essentially resellers of data plans. But instead of, so they'll buy a large chunk of data, and now one of the services they could provide is to chunk that down into very small, bite-sized plans for large numbers of connectivity devices.
Yeah, no, that makes sense. And I've even heard deploying different radio technology out there. Like perhaps it's not in the U.S. yet, but I remember hearing something about France and then it being deployed in Britain. But it still seems, I guess, still a little ways away from us here.
Yeah, and I think there's actually out in San Francisco a test deployment like that. I'm still wrestling a little bit to understand the business model with it, but there are people looking at alternative technologies. I personally think, even though I'm not a fan every month when I have to write a little check out to my carrier, but it's hard to compete with the infrastructure that they've deployed. And there's I think they're adopting data plans. I'm sure it's still much cheaper for data in Europe than it is here. I think we'll see that change over time just because the market pressure is coming. So I don't know. There are other technologies and there will be some, but I think it might be hard to compete with the infrastructure deployment that's out there today in cellular.
Yeah. Well, kind of looking out a little bit. What do you see as the future of sensors? What trends do you think are going to be happening, or that you see happening now?
Yeah, there's probably a couple trends. One is that all of us are in this quest to optimize our use of assets and resources. So that's something that's where I would say, as an industry, as across vertical markets and stuff, we're still in the very first steps of that.
Baby steps.
Yeah,
sure.
So the whole idea of business intelligence and analytics, where we're still on the front end of what we call the descriptive stage, where we're still trying to collect data on what happened, so we can figure out, how do we avoid that sort of thing in the future. To do that, to measure a process, to manage a process, you have to measure it. So that really means we're deploying a lot more sensors, and I'd say those are being deployed more aggressively in two areas. One is in new equipment. So new versions of equipment are coming with far more instrumentation and sensors on board. Even think of your car. Compare today's car with one 20 years ago, and hundreds and hundreds of sensors. So in new equipment, but that doesn't do us a whole lot of good in this industrial IoT space where,
it takes a while, right?
Yeah, and not just a few years. It's this industrial space. Things are deployed for decades. So you can't wait for like a PC refresh cycle to say, okay, my new model, it'll have all those new bells and whistles. So that's the second trend we're seeing in sensors is this deployment of these overlay networks to say, I already have a control system out there. I already have an Ethernet network, my enterprise network deployed, but I don't have anything measuring these specific attributes.
Right.
This stuff was all deployed. The EPA didn't make me measure this particular thing, or the FDA didn't make me measure, this other thing. So now I want to deploy something without disrupting my control systems, my automation systems. I want to put something in that I can grab this additional data and integrate it up to the application layer. So we're seeing a lot of take on the concept of adding in these overlay networks that help people advance from that current state of descriptive analytics and getting more towards that next stage of predictive analytics, so we can see when something's going to go wrong before it happens, and then ultimately getting to that prescriptive stage, kind of that business nirvana, to say, I know what's going to happen and when and why, and I know how to react to that.
So that's the evolution that you're seeing right now is going from, knowing what's happening to predicting what's going to happen or knowing what's going to happen to predicting what's going to happen to changing something so something doesn't happen. Is that right?
Yeah, it really is. And it's one simple example is we're talking to a large shipping company now that has lots and lots of conveyors. And when one of these conveyors breaks for any reason, then it causes them to break promises. So instead of just having a large staff on standby ready to run out and in all these different automation centers and service the things quickly, they say, well, geez, what if I monitored the current consumption of all the motors driving the conveyors? Because there's, before that thing fails, most of the time they see some sort of increase in current. Maybe there's a bearing going out someplace on the line, something that needs servicing. So they say, okay, if I could just monitor current of all these things, now I can see that something's going wrong before it happens. And now I can also get some idea of what might be going wrong, so I can get the right person with the right tools and the right replacement parts in the right location before there's a problem. And they can also react to that. They say, you know what, that motor's overheating. Maybe how about I turn line 27 down by 30%, so I can at least keep it operating, so I don't end up in a full outage situation. So I'm going to actually react to that in a kind of prescriptive way to say, okay, there's a problem there. I'm going to react to it, and I can delay the inevitable until I can get the right parts and people on site.
Yeah, no, I like that a lot, and I think you're right. It's one thing to predictive, prescriptive, but it's another thing then to quantify the value. And I'm going to not have one of my conveyor belts go down. But are you seeing the evolution of the business to basically create an ROI on this, in the sense of calculating the cost, in this example, the cost of a conveyor belt going down versus installing, purchasing the sensors, installing the network, the connectivity, the whole IoT, and measuring it, and then balancing the two out? I mean, that's obviously the real business case that has to happen. Are people doing this quantitatively or still qualitatively thinking, it makes sense that we don't burn it out and we don't go down? Or are they actually getting down to tax and calculating what these numbers are?
Yeah, we're seeing some of both. Okay. Where we see probably the people that are doing this more quantitatively today are big consumers of, are things that are kind of easy to get your head around. Like, boy, this process consumes hundreds of thousands of dollars of electricity per year, and we think there's waste there. And if we could get 10% more efficient, that's an easy one to measure, easy one to quantify. So I'd say energy and resource consumption, when you have processes and plants or things that are big consumers there, it's pretty easy for them to do the math to say, boy, this is what we're spending. Yeah. And the other one that we see that people are quantifying is the unplanned downtime. Nobody likes unplanned downtime, and all the way through the whole customer service chain, all of us as consumers have we have an extremely high expectation for customer service these days. So if something is supposed to land on our doorstep, today at 3:00, we expect it better be there. It doesn't matter that the truck broke down or the conveyor belt broke down or the coal bin overflowed or went empty. So the cost of this unplanned downtime can be huge for companies, and it's one that, and almost the numbers almost get ridiculously large, but they're true. So when somebody actually sits down and does the math and says, wow, when this conveyor breaks, on average, our mean time to get the thing repaired is 7 hours. And in that 7-hour period of time, we've had 4,000 packages that are now going to miss their delivery date. It's pretty easy for them to put numbers to that. And what they find is the numbers are huge. Usually gets people excited in a hurry, and they get ready to say, yeah, we need to do something about that.
Yeah, no, and I found the same thing, and then where I'm seeing it falling behind a little bit is then on the other side, so, okay, it's huge, but then there's the budget to eliminate that, and that's where it comes in, budgeting, products like yours, and then all the other parts of the ecosystem. But it makes a lot of sense, and I think what you say is logical in that, it's starting with the things that are easy to measure. It's the low-hanging fruit, so that's where you're seeing it most, but I love your example of the conveyor belts, the downtime. I mean, it's I'm a geek in Excel spreadsheet geek, so I'd love to get in there and start working on that. But it makes sense. It makes sense, and then tying it all together.
Yeah.
Well, Mike, really appreciate the time. I learned a lot myself. How can people find out more? How can they learn about, or how can they connect up with you? How can they learn more about your company? Where can we send people? We'll put this in the show notes also.
Yeah, that'd be great. Certainly, anybody's welcome to contact me. Give me a call here at B&B Electronics. And at my number is 815-434-8715. A great place to go look for information is we launched a new microsite just recently called bb-smartsensing.com.
Smart Sensing is all one word?
Yeah. So bb-smartsensing.com.
Okay.
And there you can just get a nice view of the Wizard platform and applications and get a real kind of visual sense of a lot of things we've been talking about.
Well, great. I will definitely have that in the show notes, and I think the next time we'll meet will be in California with you presenting at the conference.
Absolutely. Look forward to it, Bruce.
Yeah, looking forward to seeing you then. Thanks, Mike.
Thank you.
Okay, that was a good talk with Mike Fahrion. This podcast goes vertical, deep diving into different topics each week. If you prefer a more horizontal and structured approach to learning IoT business and its orbiting technologies, check out my book IoT Inc, published by McGraw-Hill, or become a certified IoT professional by completing the ICIP training and certification program. For details, just go to www.iot-inc.com. Also go to www.iot-inc.com for an analysis of this episode, links to things that were mentioned during the episode, and very importantly, the episode's PDF transcript. Just search for the name of the episode or the guest. If you're new to this podcast, subscribe. That way you'll get every week's episode delivered straight to your device. Or, if you've been listening for a while, there are 3 ways you can support the show. You can leave a rating or a review on iTunes. Just go to iot-inc.com/iTunes. It only takes 1 click to leave a rating, a little bit longer to leave a review. You can share it on social. I'm on LinkedIn, to a lesser extent on Twitter. And of course, you can support this show by buying my book, IoT Inc, or the ICIP training and certification program. It's how I pay the bills. Next week's episode is Part 1, Sensors from the Inside Out and the Outside In, with Scott Nelson of Logic PD. Hope you can join me then. I'm your host, Bruce Sinclair. Thank you for listening. Until next week, may your path to IoT business be a layered one.
You have been listening to the IoT Inc Business Show.